So, Anne.
Thank you very much. It's a great pleasure to be here today. I think most of us in this room would agree that the power of AI to transform technologies is huge. But I think AI has yet to truly fulfill its potential, in part because most of the networks that people use to drive the most exciting discoveries in AI are really based on a fairly restricted architecture, especially compared to the really very diverse architectures that we see in biological brains. So of course, the original multi-layer network, the inspiration for that came from neuroscience back in the 80s, when people realized that within the brain, groups of neurons were connected by synapses, and that their strength would change depending on learning, much in the same way that deep learning networks do now. So those observations from neuroscience were at the time pretty cutting edge, and they really were what launched AI in the direction that we see it now. But since then, neuroscience and AI have really diverged. And it might be that part of the reason for that is that at the time, back in the 80s, it wasn't obvious how additional insights from neuroscience could really help AI very much. The field of neuroscience was at a young stage, and there were many mysteries about the brain. So it wasn't really obvious how those fields could connect beyond the really basic observation that multi-layer networks had lots of different functions. So since then, a lot has changed. So within neuroscience, the field has really transformed. And at the moment, there are a lot of discoveries within neuroscience that are likely very relevant to AI. So for example, to be concrete, in my lab, we study decision making, and we trained rats and mice and humans to make the same kinds of decisions. And one sort of decision they make is that we present them with multiple sources of information that they can use to guide a decision. And these pieces of information differ in their reliability, how useful they are in implementing the decision. And we found that the animals are very good at combining them in a statistically optimal fashion. And in fact, they approximate statistical optimality even a little bit better than most of our human subjects, which is kind of surprising and maybe humbling. So we don't yet understand how the brain is able to do that, to take in these different sources of information and combine them optimally. But there are many new tools in neuroscience that have transformed the field that are making that possible. We can record from hundreds and hundreds of neurons at the same time, and we have advances now in the mathematical tools and also the computational power that make it possible for us to interpret that data and generate new theories of neural computation, and in my case, new theories of decision making. So what should we do? How should these two fields come together? They've diverged for so long, and both fields have changed so much, it's time for them to come back together. I don't know the answer to that question. I have some ideas. There could be joint conferences that neuroscientists and specialists in AI attend. There could be journals that feature articles from both fields, maybe even a social media campaign. And a final possibility is that the two groups could come together to form a task force in which neuroscientists and people from AI could work together to tackle some of the really big ethical issues that are starting to arise surrounding both these fields. So if you have some more ideas, I'd really like to hear them. I think it's time to bring neuroscience and AI back together. So come find me, and I'd love to hear what you think.